Hello everybody. Today what I'll be doing is I will be taking up question 5 for the multivariable differentiation. Anyway, let's get started. So what we basically want to do here, I'll just read the question. On the last assignment, you were introduced to a second-order partial differential equation known as the wave equation. Here, we will use change of variable to find the form of the general solution. Let p equals x minus ct and q equals x plus ct, and let u x of t equal u p q. Using the chain rule, show that star is transformed to this. So what I will do is two things. First, it says draw the chain dependence if necessary, and I will just do that just so we can work, I guess. And what I will do is over here, we have the variables u, p, and q. And then what we can see, in a way, is that over here, both p and q can both branch out into x and t. So then our dependence will look something like this. U can be a function of x and t, and then x and t can be a function of p and q. P and q. So now what I will do is, because x and t can actually be a function of p and q, what I will do is, from these equations, I will take them and I will isolate for x and t so that I know what x and t are, in essence, in terms of p and q. So let's do it. So we have p equals to x minus ct, and q is equal to x plus ct. So now, first thing I will do is I want to find out what x is. So I'm going to say that ct is equal to x minus p. So then q is equal to x plus x minus p. Q plus p is equal to 2x. X is equal to 1/2 of q plus p. Okay, now let's find what t is. So now I'm going to isolate for x. So x is equal to ct plus p. Q is equal to ct plus p plus p. And sorry if at any point my t's look like pluses. I will try to make my t's a bit curly now, like that, so it's not as hard. It's a bit harder to confuse them with the t's. So now we have that. So we have q is equal to ct plus 2p. I messed somewhere up. Give me a sec. X is equal to ct plus p. So it actually should be ct. So it's ct plus ct plus p. So then it's 2ct plus p plus q. Q minus p is equal to 2ct. Q minus p divided by 1/2c is equal to t. And there you go. Now we've isolated for t and for x. So now what we can do is we can start seeing what up of q is. So to begin with, I'm just going to go over here. So up of q is the same thing as up, or when I say up, it's just the partial derivative p. In the answers, we may have seen it as using the Leibniz notation, where it's di u over di p, di u over di p, or di u squared over di p di q. But I'm just going to write it like this, so it's a lot easier to actually see and write down, at least for me. So up, q. So now let's figure out what up is then. So up UP would be ux xp, or the partial derivative of partial derivative x and then partial derivative p of x plus uy yp. So now what I'm going to do is we can try and see what we can right away solve for xp and yp just by coming back here and actually solving it. So xp, we have up, we have xp. I'm going to be leveling up. So xp is going to be just equal to 1/2 of q. Sorry, which is going to be 1/2 is what I meant to say. And the reason for that is because, well, x is actually equal to 1/2 q plus 1/2 p. And so if we're differentiating in terms of p, then this q will just disappear and this p will just become 1. So then tp is equal to, and by the same logic, we would have 1/2c q minus 1/2c p. So then tp, this would disappear and we would be left with -1/2c. So now if we just, this is q over here. So now if we just replace that, then we're going to get equals to 1/2 of ux plus uy times -1/2c. This is q equal to, so then we can factor out in a half. So we're going to get 1/2. And again, differentials don't affect constants. So this us factoring out the 1/2 really won't do anything. So it's going to be 1/2 ux minus 1/c uy. And now we kind of reach the hard part, because now what we need to do is we need to take the second differentials, which might be hard, or partial differentials. So what we need here is we're going to need uxq, or ux of q, and uyq. So what I'm going to do is I'm actually just going to start out with uxq. Now, there's 2 ways you can view this, and I think what I can do, I'll just do it, I think, for me, the more intuitive way for now. But if you have a different way and you do it like that and get to the same answer, that also works. But here, what I'm going to do is I'm going to replace u of x with a function w. So I'm going to say that u of x, I can do it in a different color. Look at me, I'm so fancy now, guys. I'm going to do it in a different color, red. So I'm going to say that ux is equal to w xt. So now it's going to be ux of q. It's going to be w of q. And w of q, because it's of x and t, it's just going to be wx xq plus wx xq plus, wy yq. And now what we need to do is we need to replace w with what it is, which is u of x. So this is equal to u of x xq plus u x y yq. There you go. And now, because uy is symmetrical, it's actually going to be end up the same thing. But we could do it the same way, where we're going to get wq. And again, you could just think of it as uy is equal to wy yq plus wy y p q, w y y q, w y. So here it should be wx xq. Sorry if I confused anybody. And then again, we can replace it, so we get u y x xq plus u y y yq. Okay. So now what we could do is, before we actually plug it into here, I just want to simplify it quickly. And again, the way we can do that is we can just take everything in respect we can try taking things in respect to q now. So xq would be equal to 1/2, and tq would be equal to, tq would just be equal to, so now we would be, so this would disappear and it would just be equal to 1/2c, like that, because the negative would be gone. So if we were to then make it equal, so then uxx, so xq is 1/2, so we get 1/2 uxx plus uxy, and then yq, Okay, so when I was saying y there, what I really meant to say was t, because our two variables are x and t. I'm sorry if that confused anybody. It just confused me and finally, but all of these should be t's, not y's. But hopefully that doesn't make, hopefully that didn't really confuse anybody too much. But again, just imagine all the y's are t's, and I'm replacing them right now. But yeah, so y, t, tq, t, t, tq. So here it's ut, tq, wt, tq. It's going to be ut, tq. Okay, and then over here, what we're going to get is, okay, and then this is u, tx, and then it's uxt. Perfect. So now utx. So utx xq. So xq again is just 1/2. So it's 1/2 utx. I really need to learn how to write superscripts and subscripts. So utx plus utt, and then it's 1/2c. 2c. So now let's try to plug everything back in. So we're going to get 1/2 of, so ux is over here, so it's uxx, 1/2 of uxx plus uxt, and I think I forgot to finish writing here, uxt, tq is 1/2c, 1/2c, so plus uxt times 1/2c. Sorry guys, I know I'm committing a crime by writing it to the right instead of the left. I apologize. Minus 1/c. So then it's 1/2 utx plus utt 1/2c. Okay. So now, if we, so now if we start canceling things out, we're going to get 1/2 of 1/2 uxx plus uxt times 1/2c minus 1/2c utx minus utt over times 1/2c squared. There you go. So now this and this cancel out. So then we're left with 1/2 of uxx. And when I'm saying xx again, it's just partial derivatives, minus 1/2c squared utt. We're going to factor out 1/2. So it's going to be equal to 1/4 of uxx minus 1/c squared utt. And now what we're going to do is we're going to go back up quickly. We're going to see that utt is equal to c squared uxx. C squared uxx. So that means that 1/c squared utt is equal to uxx, right? And so what we see here is that if we just replace uxx with equals with 1/4 of 1 over c squared utt minus 1 over c squared utt, this will just become 0. And that is actually what we were trying to show over here, that UPQ, because remember, all of this is just UPQ. All of this we were going down, and we wanted to prove it's 0. So that's what we just did. So now what it's asking is it's saying, use partial integration to find the general solution UPQ to star star, which is over here. And let's write down the general solution for star, which is over here. Okay, so let's do it. So what we want to start with then is when we're looking for the general solution, it's saying partial integration. Okay, and so what we're going to do is we're going to integrate that. And that's the general gist of it. So we're going to take our function, which is UPQ right now, and then we're going to integrate the right side as well. And because there's a Q here, or I think, okay guys, here, it's more of me thinking, because I'm not super duper sure, but this is my general understanding and my understanding of it. I know I said understanding voice, but UPQ, because we have a Q here, we want to first do, because if you're thinking about it as a integral, as the opposite of derivative, you want to take dq first, because we're going to take the integral of dq. So equals to integral of 0 dq. And so the q and the dq cancel out, like we remember from last term, because a derivative and integral cancel each other out. So we're going to get up is equal to, and this means the partial derivative p in respect to u, is equal to fp, where f is an arbitrary function. And the reason we're left with fp and not fq is because if we actually look at a lot of these functions, and this is again my speculation, is that we see that when we actually take the derivative of q, we get left with something of p. So like sometimes, because if we're saying, for instance, we have q 1/2 of qp, like let's say our function of p is 1/2 qp, and then if we differentiate it in terms of p, we're going to get left with 1/2 p. So I think that's why it's in terms of p over here. And then what we're going to do, because now we have a p over here, we're going to take it in respect, we're going to integrate it with respect to dp. So we're going to integrate, so it's going to be up dp is equal to integral of fp dp. And here we're just going to be left with u of pq, so that's the actual function in terms of p and q, is equal to fp plus gq. And fp is just the integral of this, so that's like if you integrate, if you differentiate this, you would get this capital F, and then gq would disappear if you integrate in terms of p. So then what we're going to do just in the end, we're going to replace our p and q with what we had in the beginning, with what we were given. So p is equal to x minus ct, and q is equal to x plus ct. So over here then, we get u p q is equal to f x minus ct plus g of x plus ct. And there you go. That's our answer. I hope this helped, and I will release question 6 as soon as I can. Stop it.